So for our next way to try and solve systems of linear equations, we are going to look at a different way to do it. And it's sort of represented by this right here, a boat car. Now, a boat car is one of those great things that's out there. It's part boat, it's part car. It can do both. It can do different things, and et cetera, et cetera, et cetera. And you're not sure if you want a car or if you want a boat, so why not put the two together? And now, in order for that to work, though, I mean, there's certain things that the boat and the car components have to share. I mean, there's only one set of seats. It uses usually one kind of motor. There's certain components that they have to share. Now, some components can be different. They can be just for the car component or the boat component. But there are simple things and complicated things both that they must share a common bond with in order to come together. Now, this is the basic idea behind the next method of combining equations, and that is to combine equations by using what's called substitution. Now, in substitution, it's all about taking two things and putting things together with a common bond. So basically the idea is you have two things, and what you do is you combine using a common bond, so to speak, or common value. Okay, so there's certain things they have to share in order for them to come together. Okay, so same as a boat car, they have certain things that they have in common. You can put the two things together, but they still have individual things that are a little bit different. But that's the basic idea behind substitution. So if you have two linear equations, maybe we have here, let's use 2x plus y is equal to 6, and you have x plus y is equal to 5, and you want to solve this system. Now you could graph it, you guys have worked that as well, but we're going to work on substitution. And in order to do substitution, we need to combine these two things together like the boat car. We need to put them together. But in order to put them together, they have to have a common bond or common value. And that's really, really simple. One common bond, common value that we can use is y. Another one we could use is x. They have those in common. And we want to use the x and the y, not a number, but we want to use the x's and y's because we want to try and actually get rid of one of them. And we can do that by substitution. So we can actually substitute one expression into the other one and sort of bind them together. Now let me sort of show you what that means. Let me take the top expression. We'll leave the top expression the way it is, okay? 2x plus y is equal to 6. I'm going to leave that guy alone, okay? I'm not going to do anything. But what I'm going to do is I'm going to take the bottom expression and I am going to change what it looks like. And when I change what it looks like, I can move things around. So what I'm going to do is I am going to subtract x from both sides. So I'm going to subtract x, and of course those x's cancel out. That's going to leave me with y is equal to 5 minus x. Okay, so that is what I'm going to do with that guy. Just rearrange it a little bit. And now what we can do is I can actually substitute into the first expression. I've got 2x plus y is equal to 6, but y is also equal to this right here. So those two y's are the same. There's no difference between those two y's. So instead of having this as a y in this expression, since these two parts are equal to each other, I can take this and I can substitute that in there, and that's why it's called substitution. I can substitute that. So if I rewrote this again, it would be 2x plus, but instead of writing y, I'm going to substitute it with something that's equivalent to y, which is 5 minus x. So 5 minus x, and that's equal to 6. So that 5 minus x, that's just the y value. That's just this y value, but they're the same. So that's why it's called substitution. So we have something that looks like this. Now, instead of having an equation with two unknown values, which can't be solved, I only have one unknown value. I just have to simplify it. So as I simplify this, I decided to put like terms together. So I've got 2x over here plus a minus x. That would just be x. And then I've got the plus 5, so it's just plus 5 is equal to 6. Subtract 5 from both sides. That cancels off. And of course, then x is going to be equal to 1, and it is solved for. And that's sort of how substitution works. Now, I can do this a different way as well. I could then substitute for y, or sorry, solve for x instead. I could substitute for x and solve for y. So there's different ways you can do it. Now the thing is, I found my x value. My x value is 1. All right. Well, then I can take that value and I can put it back in the original expression like this guy right here. I know my x value is 1, so 1 plus y is equal to 5. Well, then I know my y value must be equal to 4. So once you solve for it, you take it back and you put it back into the original expression. Okay, so we just did this question by substituting for y. But I can do the exact same thing substituting for x. What if I'm going to take the exact same expression, 2x plus y is equal to 6, and x plus y is equal to 5. Okay, I'm going to do the exact same thing. I'm going to keep this one the way it is, 2x plus y is equal to 6. And this one, I'm going to change it up a little bit. I'm going to change it to and solve for x. So x would be equal to, move the y to their side, 5 minus y. And then what I'm going to do is I'm going to substitute this in for the x. So up here we substitute for the y. Here I'm going to substitute for the x. Okay, so if I rewrite that top one again, that would be 2 instead of writing x, I'm going to write 5 minus y. And then be plus y is equal to 6. So now I'm going to solve this one. So this would be, if I'm going to multiply the bracket, so 10 minus 2y plus y is equal to 6. Put like terms together, 10 minus 2y plus y would just be minus y equals 6. I can then subtract 10 from both sides, so minus 10 is equal to negative 4, and then y will just be equal to 4, which is exactly what we had before. And if I put that 4 back in here, that tells me that x has to be equal to 1. So you see, it doesn't really matter which one you actually solve for, whether you substitute for the x or substitute for the y, it really doesn't matter. But often you want to try and substitute for the one that makes things easier, and you sort of see what you prefer, stuff like that. But often you can tell which one is going to be easier, and you'll always end up with the same answer as long as the algebra all works out. Okay, so that is the basic idea behind substitution. So let's take this and shrink this down. Okay, and let's sort of look at what we did here. Okay, so if we look at what we did, there's certain steps to doing this, and it's relatively straightforward. So usually what people will do, often for step 1, what you'll typically do is you will solve for one of the variables. And the first time we solve for y, the second time we solve for x. Okay, step 2, okay, then we substituted that expression for the variable in the second expression. Okay, and we'll lay out this out more, do some more practice. And then number 3, we could solve. And then the fourth thing that we did is go back in order to actually find the other variable. Okay, so that's generally what we did overall. Okay, so kind of messy the first one, sort of laid things a little bit. We'll do some more things to clean things up a little bit and look at this a little bit more. Okay, so let's get rid of all this stuff over here. Let's clean this up. Let's get rid of that. Let's get rid of this. I'm going to take this. I'm going to keep this around. I'm going to move it over there and do some more examples here. Now that things are laid out. Okay, so we are going to try this one. So I've got minus 2x plus y is equal to negative 7. And I'm going to write them side by side. It doesn't really matter. I'm going to write them side by side. I got 6x plus 8y is equal to negative 12. All right, so these are the two that I want to solve for. Okay, now what you want to do, first of all, solve for one of the variables. And it's usually easiest if you solve for a variable that's all by itself. That's often one of the easier ways to do it. Not necessarily, but it's often a good way to start. So if I look for a variable that's all by itself, it is going to be that one right there. That one's all by itself. That's probably going to make things easier. Okay, so if I solve for this expression for y would, you've got to add 2x to both sides, so plus 2x, I would get this. So I solve for one of the variables, and again, usually you want to try and go for one by itself. So I got y is equal to negative 7 plus 2x. So my second step is then to substitute that into my second expression. So what I want to do is I want to take this value right here and substitute it in for that y value right there. Okay, so there's my substituting for variable in the second expression. So I'm going to rewrite my second expression with that in there. So I've got 6x plus 8. Really good idea to include brackets. So now I've got this. Okay, so now I've got to try and simplify. So we're going to have to multiply with the brackets. So I got the 6x plus, I got 8 times negative 7, so that's going to be negative 56. So if you want, you could just do negative 56 to begin with. It doesn't matter. So I'll take away 56, and then I got positive 8 times 2x, so that's going to be plus 16x is equal to negative 12. Okay, so now I want to combine like terms together. Okay, so I've got 6x, I've got 16x, so that's 22x's, is equal to, let's see, I've got to add 56 to this side. I'm going to have to add 56 to that side, which is going to give me 44. So I'm going to divide by 22 on both sides, and that will leave me with x equal to 2. All right, so I've got x is equal to 2, and that's the solving part here, number 3. So I just solved, and x is equal to 2. And now what I can do is I can take that value of 2, go back to one of the original expressions. It doesn't matter which original expression you choose. It'll be the first one, the second one, doesn't matter. And I can use that to solve my other variable. So I'm just going to use this one's a little bit simpler. I've got negative 2. I know x value is 2. I know my x value is 2. Plus y is equal to negative 7. So negative 2 times 2 is negative 4. Plus y is equal to negative 7. I'm going to add 4 to both sides. That's going to cancel out here, and I'll be equal to y is equal to minus 3. So y is equal to negative 3. Okay, and I can do a little check here. I can figure out if I'm going to be right or not. If I take my original expression I had up there, and sometimes it's a good idea to check. I've got minus 2x plus y is equal to negative 7. My x value was 2. My y value I found was negative 3. So let's see if this works. Negative 2 times 2 is negative 4. Negative 4 plus negative 3 is negative 7, so it checks out. And if it works for one, it should probably work for the other one as well. And actually, it should work for the other one as well. Okay, so there is your basic solving by substitution. Okay, so again, solve for one variable, substitute it into the second expression once you've solved for it. And then you can solve the actual expression and then go back and find the other one. So that's all sort of laid out. Okay, so in the next video, we'll do some more practice questions and do some more work with the different things in part of the substitution type method.